Power n.
No, here to get 14-bit address. So how do you get 14-bit address? This is what we had calculated, right? Solution, see there. Since the samples arrive at a rate of 50 kilohertz, that is 50 per milliseconds, 1 over 2 to the power 3. So 50 per millisecond. So we need to store up to how much? 255 into 50, 12,750. So if you do this, log of 12,750 to the base 2, it's a ceiling function. Ceiling means rounded off, ceiling function. How much you had got?
13 point something, ma'am.
You had got some 13.9 or something, right?
Yes, ma'am.
Ceiling of this value means you have to take it as 14.
Yes, ma'am.
This is very important. Deciding how many bits address line you need is very important. If you cannot do this calculation, then any problems you will be unable to do. So this is very important, 14-bit address.
Yes, ma'am.
So that's why. So 2 to the power 14 is how much? So if you do this, 2 to the power 14 is how much?
Okay.
16K. Are you getting this? 16K is how much? 1024. Are you getting this? How much you will get? 2 to the power 4. 2 to the power 14 is 16K. How much you got? 16 into 1024. How much you got? You have the calculators with you?
Ma'am, 16,384, ma'am.
Huh?
16,384.
But we need to store only 12,750, right?
Yes, ma'am.
But we cannot use this lesser memory because 16K, yeah, only memories are available in standard form, 1K, 2K, 4K, like that, 4K, 8K. 8K how much you will get? Then 16K. 8K how much you will get? 8 into 1024.
8,192, ma'am. 8,192.
8,000?
192.
So no fan 8,000?
192, ma'am.
8,192. So this memory we cannot use, right?
Yes, ma'am.
So 8K we cannot use. That's why we are going for 16K. As standard memories are available, even though we don't use all the locations. 16K into 1024 ಎಷ್ಟಾಯ್ತು ಹೇಳು? Something you said. What value you had told?
$16,384, ma'am.
ಆನ್ಸರ್ ಆಕಾಶ್ ಎಲ್ಲ ಏನ್ ಮಾಡಕತ್ತೀರಿ ನೀವೆಲ್ಲ?
16384, ma'am.
ಎಷ್ಟು?
16384.
16K into 1024 ಎಷ್ಟು?
16,384, ma'am. 384.
I cannot hear you. 16,000?
384, ma'am.
384 locations. So
Yes,
even
ma'am.
though you have full memory 16,384, but I will be needing only up to 12,000. That is more than enough. These many locations will be free. But if I use the lesser memory, 8 kilobytes memory, then I cannot accommodate all the samples. That's why I am using 16K here. Is it clear to you all?
Yes, ma'am.
Why we need to go for 16K? This is very important. Then why the address bit is only 14? This is important because depending on our problem, we need to store 255 into 50. That is 12,750 samples. That's why address bit is 14. If you don't understand this calculation, further we need to composite memory ಮಾಡುವಾಗ you will not understand anything. Right? Already in the last class I had told this. So that's why the counter also, address generating counter, the counter here we had taken as 14 bits counter. That means address will be generating from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. After 9, what will be the next address? After 9, what will be the next address? 0 to 9. After 9, what will be the next address?
A, ma'am.
Huh?
A.
Who answered that? Very good. A, B, C, D, E, F. After F, the next address is
10, ma'am.
10. Very good. 10 to again 10 to 19. After 19, 18 to 1F. Then after 1F, again 2
Solve
0.
kodo.
Like this only it will be going on up to FF. So hexadecimal counting. After FF, it is 100. This is very important. Right? So, you can tell me one more this. One more important question for you here. Where, okay. How do you calculate the starting and the ending address? We were calculating here. I was showing you. Okay. We were calculating here 16K cross 16. So 16K. 16K was how much? 16K was how much? 16 into K is 1024. 16K into 1024 is something you told. It is 16,384,
84, ma'am.
384. Very good. How do you calculate the starting and the ending address? Starting address is 000. Okay. What is the ending address? Can anybody tell me? Whoever says, you will get 1 marks extra. What will be the ending address if the starting address is 00? What will be the ending address in hexadecimal?
4F, ma'am.
Huh?
F, ma'am.
All FFs? How many
Yes,
FFs you got?
4, ma'am.
4 FFs. So how do you do that? 16,384. If this is in decimal, if you calculate in hexadecimal, this will be what will be 16,384 in hexadecimal? You'll have to subtract 1 minus 1 because 0 is also your memory address. So 16,383. So if you do, then you'll get the equivalent hexa. You'll get all FFs. Check all of you. See, for the especially for memories chapter, you need the calculator in your hands. Are you getting that address? All 4 F's you are getting. What she has told is correct. Yes. Is it okay? 16K. Starting and ending address is 4 zeros to 4 F's. Is it okay?
Ma'am,
For 16K.
Ma'am, I got
Can
1 3
anybody
and
tell me
3 F's.
whatever answer she has given, is this right or wrong?
Ma'am, I got different, ma'am.
What value you got, Akash?
First one 3, ma'am. 3 Amel 3F, ma'am.
That's what you will be going to get it as 3 FFF is the answer.
Yes, ma'am.
All 4 F's means this is for 64 kilobytes. You check, Akash, for 64 kilobytes. Will you get this or no? What is the starting and the ending address for 64K? You just see. So how do you calculate again? 64 into 1024. Whatever value you get, that minus 1, because always 00 is our first address. Then minus 1, whatever data you will get, convert that into hex. So you are going to get the starting and the ending address. So for 64K, what is the ending address? Sandhya, ಯಾರು ಆನ್ಸರ್ ಮಾಡಿದ್ರಿ ಇದನ್ನ
4F,
ಕರೆಕ್ಟ್
ma'am.
ಮಾಡ್ಕೊಳ್ರಿ. For 64K, what is the starting and ending address?
00 to 4F,
4
ma'am.
zeros to 4 F's is the starting
4F.
and the ending address. Whereas for 16K, the starting address is 4 zeros to 3 FF is the answer. How many 16K memories we need to have 64 kilobytes of memory? ಈಗ ನನ್ನ ಹತ್ರ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಬರೀ 16K ಇದೆ. ಓನ್ಲಿ ಐ ಹ್ಯಾವ್ 16K. I need to compose 64K ಬೇಕು ನನಗೆ memory. So how do I do with 16K? How do I do with 16K? I need 64 kilobytes of memory. I have only 16 kilobytes of memory adhav nan kade. In store, lot of 16 kilobytes of memories are there. I want to make 64 kilobytes of memory. So what I can do?
We can use 416K.
I can take
416K memories.
416 kilobytes of memory will suffice 64 kilobytes of memory. Very good. That's what will be our next topic. So now is it clear to you all of you? 255 into 50 antandre I need 12,750 samples I have with me. So only standard memories are there, 1K, 2K, 4K, 3K, 5K hangilla, 4K, 8K, 16K, powers of 2, 16K, like that. So if I use 8K, then it doesn't suffice. So if I use 16K, additional memory, some part will be left, there is no problem, right? So what I am doing, I am using 16K memory is being used, right? So to address this, how many address lines you need means what you have to do, take the logarithm ceiling function of this, log to the base 2, you will get the address bits. So you need 14-bit address. And what else I told you, how to calculate the starting and the ending address. So that equivalent value -1, why -1? Because 0 is also our starting address. Then convert it into hex, so you will get the starting and the ending address. Is it clear to you all of you?
Yes, ma'am.
Very, very, very important concept of electronic students. This you cannot forget. More of memories and electronics idu niಮಗೆ ಗೊತ್ತಿಲ್ಲ ಅಂತಂದ್ರೆ ಉಪಯೋಗ ಇಲ್ಲ. This is very important. Each and every student, electronic student must know this, right? So what I was teaching you all, okay, so what I was teaching, see here, again I asked you here, so maximum delay is 255, need to store 255 into 50, so that's why. So if t plus 12,750 samples, so use the 16K plus 16-bit memory, and we need 14 address bits. See there, 16K cross 16-bit he has told, right? 16K cross 8-bit use ಮಾಡಿದ್ರೆ ಎಷ್ಟಾಗ್ತದೆ ನೋಡಿ ಅದಕ್ಕೆ. This is also dependent on us only as a programmer, whether you need 16-bit or 18-bit also you can decide on your own, right? So here we are using 16K plus 16-bit memory. So if audio in is at a time, yes, if audio in time is at st, then audio out will be t minus d, so delay by 50 samples. So here t plus 1 if it is there, then t minus d plus 1, so again delayed by 50, that memory location. That means in memory, if this is the location you are telling, then after 50 bytes, if this is there, then if you are taking the next memory location, then parallelly you will be taking from the next memory location from here. So that is very important. Okay, so that's what. So the control sequence for the unit involves 2 steps. So audio delay control section. The control sequence for the unit involves 2 steps. When the samples arrive, indicated by an audio in enable being 1. So when the samples arrive, audio in enable will be 1. Set the multiplexer to use the counter value as a memory address. That means that multiplexer whatever is there, so multiplexer 0, 1 is there, so counter is being used, directly the counter value. So whenever that audio in enable, so when the samples arrive indicated by an audio in enable being 1, set the multiplexer to use the counter value as the memory address and enable the memory to perform write. So that memory read write enable is there, so this write should go high. So what will happen? The memory will be written. Data will be written here. So very clear. When the samples arrive, set the multiplexer to use the counter value as a memory address and enable the memory to perform write. Then next, set the multiplexer to use the subtractor, because here one subtractor will come here. So there is one subtractor. Subtractor symbol in graded. There is one subtractor, arithmetic logic unit. There is one subtractor here. So the multiplexer will use the subtractor output as the memory address. Enable the memory to perform the read operation. So that time when you want to make it as read, so 0 has to be sent on the memory line. Read, set the audio out enable to be 1. So audio out enable also should be 1. You are reading from the memory. Set the audio out enable 1 and enable the counter to increment on the next clock edge. So again the counter has to be incremented on the next clock edge. Right? So use step 1 as an ideal state for the state machine that controls this sequence. Is it clear, all of you? Is this clear?
Yes, ma'am.
Any doubts you have? Entire class, very important. So only
No, ma'am.
when audio in enable goes high, the data is read. Only when audio out enable is high, then only the data is read from the memory. So this is coming on the audio in lines, which is connected to audio in line is connected to what? Audio in line is connected to the data in D in line, and audio out is connected to the D out line. So only when this goes high, then the data is out. Only when this was high, then only the data is in. So this is what is being shown. See there. Audio in, 16-bit audio in is connected to the data in. Audio out is connected to the data out. Right? So depending on the multiplexer, when it is 0, directly the counter address is taken. When it is 1, then the address is subtracted and it is delayed. Is it clear to you all?
Yes, ma'am.
All of you. Any doubts you have not understood? Is it clear to you all?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now we will go to the control section. So how it is being done? Control section, see there. Step 1 is taken as the ideal state. Audio in enable is 0, do nothing. When audio in is 0, then we are not doing anything. When audio in enable is 1, then what should happen? When audio in enable is 1, what should happen? All of you tell me. Audio in enable 1 ಇದ್ದಾಗ ಏನಾಗಬೇಕು?
Data store
Data?
will be storing, ma'am.
Uh,
Data will be
data
stored in.
is stored in the memory. So write memory operation. Storing the data into the memory is write memory using the counter value address. The next step 2. In steps 2, read the memory using the subtractor. Read the memory using the subtractor output as the address. Next, increment the counter. So how do you write? See there. Step 1, audio in enable is there. Audio in enable, if it is 0, then the next step you see there. Next state is state 1 only. Do nothing. See, all are 0. Do nothing when audio in enable is 0. So be in step 1 only. Right? So transit from step 1 to step 2 only when audio in enable is 1. So when audio in enable is 1, what will be address select, memory enable, memory write, counter enable and audio out enable signals? In step 1, what will be the address select in step 1? What will be the address select?
0,
in
ma'am.
step
0,
1?
ma'am.
Why it will be 0? You are taking the address from where? Address is generated from where? Why 0? Address is generated from where? Address is generated from where if it is equal to 0? If address select is equal to 0, then address is generated from where?
Mux, ma'am.
Huh?
Mux.
Not mux. Mux value only is 0. No, address select is connected to the mux, ma.
Counter, ma'am. Counter value.
Directly from the counter. ಡೈರೆಕ್ಟ್ಲಿ ಫ್ರಮ್ ದ ಕೌಂಟರ್. ಏನ್ ಅವಾಗಿಂದ ರಾಮ್ ಸೀತಾಗ್ ಎಷ್ಟು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ ನಾನು ಕಲ್ಸಕತ್ರ ಎಲ್ಲೆಲ್ಲಿ ತಲೆ ಇಟ್ಕೊಂಡಿರ ಏನ್ ಗೊತ್ತಿಲ್ಲ. ಇಂಥವಕ್ಕೆಲ್ಲ ಇಫ್ ಯು ಸ್ವಿಚ್ ಆನ್ ಅಂಡ್ ರೋಮ್ ಅರೌಂಡ್ ಆರ್ ಇಫ್ ಯು ಡೋಂಟ್ ಕಾನ್ಸಂಟ್ರೇಟ್ ನಥಿಂಗ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಹ್ಯಾಪನ್. ಸಿಂಪ್ಲಿ ಅವರ್ ಬ್ಲಡ್ ವಿಲ್ ಬಿ ದಿಸ್ ಇಯರ್. ಏನ್ ಯೂಸ್ ಇಲ್ಲ. ಏನ್ ಹೇಳಕತ್ತೀನಿ ನಾನು? ಅಡ್ರೆಸ್ ಸೆಲೆಕ್ಟ್ ಸಿಗ್ನಲ್ 0 ಇದ್ರೆ directly the address is generated from the counter. There is no delay or nothing. ಏನೇನ್ ಆಗಂಗಿಲ್ಲ ಇಲ್ಲಿ. ತಿಳಿತಾ? ಅಕಸ್ಮಾತ್ ಆಡಿಯೋ ಎನೇಬಲ್ 0ನೇ ಇತ್ತಂದ್ರೆ ಇದೆಲ್ಲ ಏನಾಗಂಗಿಲ್ಲ. ಆಡಿಯೋ ಎನೇಬಲ್ 1 ಇರಬೇಕು, ರೈಟ್? 1 ಇದ್ದಾಗ ಅಡ್ರೆಸ್ ಸೆಲೆಕ್ಟ್ 0 ಇತ್ತಂತಂದ್ರೆ directly we are taking the value from the counter. This is what I am asking. When it is 1, then this is through the subtractor. It is delayed by 50 samples. That's what is asked. So see here. So step 1, audio in enable has gone high. So address select is 0. Means what? Directly the address is generated from the counter. That's what? Write memory using the counter value as an address. Directly the counter value is treated as an address. So memory enable should be 1, and memory write, you are writing into the memory, so memory write also should be 1. Then count enable and audio out enable are 0 0 because you are writing. Then in step 2 you are reading from the memory. So when you read from the memory, what should be there? Writing correct memory location ಗೆ ಆಗ್ತಿರ್ತದೆ. ರೀಡಿಂಗ್ ಮಾಡೋದ್ನಾಗ ನಾವು ಏನಾಗ ಮಾಡ್ತೀವಿ? ಎಕೋ ಇಫೆಕ್ಟ್ ಬರೋ ಸಲುವಾಗಿ 50 milliseconds ಡಿಲೇ ಆಗಿದ್ದ ಡೇಟಾನ ರೀಡ್ ಮಾಡ್ತೀವಿ. ಅದ್ರ ಸಲುವಾಗಿ ವಾಟ್ ಈಸ್ ಡನ್ ಇನ್ ದ ಸ್ಟೆಪ್ 2? ಸಿ ಹಿಯರ್. ಸ್ಟೆಪ್ 2 ಏನಂತಂದ್ರೆ ಆಡಿಯೋ ಇನ್ನದ ಕಂಟ್ರೋಲೇ ಇಲ್ಲ. ಒಂದು ಅನ್ಕಂಡೀಷನಲ್ ಟ್ರಾನ್ಸಿಷನ್ ಇದು. ಸ್ಟೆಪ್ 2 ಟು ಸ್ಟೆಪ್ 1 ಮತ್ತೆ ಆಡಿಯೋ ಇನ್ ಎನೇಬಲ್ 1 ಮಾಡೋದು ಬೇಕಾಗಿಲ್ಲ. Okay, so address select is 1. That means what? So the address generated will be delayed by 50 samples. Then memory enable is 1. Memory compulsory enable agbeku. Memory write has gone 0. Why memory write has gone 0? Why memory write I am writing it as 0?
We are performing read operation, ma'am.
Very good. Because read write is done on a single line, so memory write is an high signal there. So that's why whenever high signal comes, writing will take place. Whenever low signal will come, the reading will take place. So now in the step 2, I want to read the memory. So in step 2, I want to read the memory using the subtractor output. So because of subtractor output, this address select has gone high. Then so memory enable, at least this has to go on high only. So memory read write, this has gone 0 because I want to read from the memory. Then count enable has to be 1 and audio out enable has to be 1 because from audio out enable, so data out is there. So whatever data is there in the memory, that is going at the output side. Is the control signals generated for audio delay unit clear to you all?
Yes,
Yes,
ma'am.
ma'am.
All. So how the control signals are generated is clear. Okay, so in step 2, address select is 1, memory enable is 1, memory write is 0, count enable is 1, and audio out enable is 1. Alright, this is the control section for audio delay unit. So is this problem clear to you all? Audio delay unit example? You will get this question compulsorily for 10 to 12 marks. Write the data path for audio delete unit. Data path. So data path means you have to write this. audio unit example Datapath, then explain with respect to the waveforms, then the control section, how the control signals are generated for audio delay unit. Is it clear to you all?
Yes, ma'am.
Yes, ma'am.
So whenever you come for the next class, you update all this waveforms and this table, you update and come. We'll go to the next example, wider memories. So already I gave you that. So I wanted to. I was having 16 kilobytes of memory. So I wanted to make it 64K. You said I need to use 416K. So like this, I will use 416K kilobytes memories to make as 64K. So this is increasing the length of the memory, right? Think now, if I have 64K cross 8, I want to 16K cross 8. All these are. I want to make of 16. So then what I should do? I have to even increase the width also. So I need total how many? 16K cross 4, how many I need? Total 8 I need, because I want to increase even the width also, because each one is 8 bits. I want to store 16 bits. So here I have increased the length as well. I have increased the width of the memory. So the next topic is wider memories. That means how do I increase the memories? Length or width, right? So see here, memory components have a fixed width, that is 1K, 4K, 8K, 16K, like that. So use memory components in parallel to make a wider memory. For example, 316K cross 16 components for a 64K cross 48 memory. See there. What is being done? I am having 16K cross 16 memory, right? Components. I want to make 16K cross 48. Width I need to increase, right? 16 means what? The data out will be D out is 16 means what? 0 to 15. Total 16 bits, right? Next 48 I want. So next 32 bit. What will be there? Next up to 15 is here. Then next 16 to 31 D out. Then next will be what? Next 32 to 47. So total length is from 0 to 47. So I can increase the width of the memory. So what is being done? You can just see there. Enable write A0 to A13. Address bus will remain the same. Only the data will change, because I am increasing the width. Rather than showing like this, I would have shown horizontally also like this. Right? It is better if you would have shown, because address remains the same for addressing 16K. 0 to 13 means how many address lines you were needing? 14-bit address. Right? So that's why what you observe here, enable is there, write is there, address is A0 to A13. So you check all the enables are being connected, all the enables. Then next all the writes, right? Then next all the address lines A0 to A13 is connected to all, right? The only change will be the data bus D into, the only change is see here, data in 0 to 15. Data in 0 to 15 is there, data out 0 to 15. But for here exclusively, data in is 16 to 13. We are not combining, because I want to make this 16 bit as 48 bits. So that's why D in again separate 16 to 31. So D in next 16 bits. So separate exclusive D out 16 to 31. Then next separate line D in 32 to 47. Then next D out 32 to 47. So like this we are making 16K cross 16 memory, 16K cross 48 memory using 3, 16 ಇದೆ ಇಲ್ಲಿ. So 16 into 3 if you make, so 18, then you will get 48. So to make 16K cross 48, I need 3 16K cross 16, right? So only the data in data bus is changing here, whereas address bus, when I give the same address, what will happen? What will happen? Think now. If I give on all the 316 lines, if I give the address as 1 now, what will happen? From this address 1 location, 3. If I give address as 1 for this fellow also, for this fellow also, and for this fellow also, address bus is connected same. What data I get from here? What data I get from here? What data I get from here? Akash, tell me. Same address bit is connected. Address location 1 ಅಂತ ನಾನು ಸ್ಪೆಸಿಫೈ ಮಾಡಿದಾಗ ಏನೇನು ಡೇಟಾ ಬರ್ತದೆ ಇಲ್ಲಿ? Same address line is connected to all the 3. What data you will get here? I will get the data here from 0 to 15, and from the second memory I will get the data from 17 to
16 to 31.
Sorry, 16 to 31. Then from here,
32.
fellow I will get from 17 to
32 to 47.
32 to
47.
32 to 47.
47.
Just I gave you the example of address number 1. Now if I get, see, 16K the maximum address ಏನಿತ್ತಲ್ಲಿ 3FFFF address ಇತ್ತು, right? So if my address is now 3FFFF is the address. So if I give the same address to all the 3 memory locations, what will happen? 3 memories are different. So from here I will get the data from 0 to 15, here 16 to 31, here 17 to 47. So in this case I am increasing the width of the memory from 16 to total how much? From 16 to 48. The length remains the same. So each memory is having 64K only. Is it clear to you all?
Yes, ma'am.
So very important. Any doubts you have? So quickly you can take this figure, all of you. One second. ಇದು ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೂ?
Yes, ma'am.
Yes, ma'am.
Is it clear to you all of you? You can draw this at home. We'll go to the next slide. So that's why more locations. To provide 2 to the power n locations with 2 to the power k locations, components use 2 to the power n by 2 to the power k components. So this is very important. ಈ formula ನೆನಪಿಟ್ಕೊಳ್ರಿ. To provide 2 to the power n locations with 2 to the power k location components, use 2 to the power n by 2 to the power k components. This is very important. Address A at an offset A mod 2 to the power k. This has to be done. So least significant k bits of A. So in component ಇಲ್ಲಿ ನೋಡ್ರಿ ಸೀಲಿಂಗ್ ಆಯ್ತು. ಈಗ lesser value A divided by 2 to the power k ತಗೋಬೇಕು. So the lesser one whichever you will get, that you should take. So most significant n minus k bits of A. So decode to select the component. So the same thing is being shown here, right? This is very important. So now next one problem is there. Better we'll do that. So design 64K cross 8-bit memory. See there. You need to design 64K cross 8-bit composite memory using 16K cross 8-bit components. So all of you quickly do this and show me. Design 64K cross 8 bit composite memory using 16K cross 8. This width is remaining same, 8 only is there. 16K, you will have to make it as 64K. So you just tell me, how do you do? How many you need, you tell me?
3 ma'am. 4 ma'am.
16K cross 8 ide. How many you need? How can you do that? Quickly, all of you can draw and show me. Can you draw that? Can you draw the figure, all of you? Design 16K cross 8. 4 composite memories you need to do. See there. All of you concentrate here. All of you are with me?
Yes, ma'am.
See, what I need to do is very important. What I need to do, I need to design 16 4K cross 8 bit memory, composite memory using 4. He has told 4 16K cross 8 bit components. The solution is, look at the solution here. The solution is address bits 14 and 15 are decoded. Why I need to decode 14 and 15 are decoded? To select which of the 4 memory, ಯಾವುದು width same ಐತಿ, ಯಾವ memory select ಮಾಡ್ಕೋಬೇಕಂತ ಕಂಡುಹಿಡ್ಕೋಬೇಕಲ್ಲ. So address decoding is done. Decoding is done here. So bits 15 and 14 are decoded to select which of the 4 memory components are enabled for either reading or writing operations. So those bits also control the multiplexer to select the output data from the enabled component. So you can see there by address 14 and 15 what is being done. So see there, A0 to A13 are going directly, all are connected, whereas 14 and 15. So how do you do this? I'll just show you. $16K. What is the starting and ending address of 16K? You tell me. Previously you told me that answer. What is the starting and ending address of 16K memory?
0002 3
0 0 0 0 to
3 FFF.
3 F F F. So what I will do, I will not touch this because they are changing lines. First ಎಲ್ಲ 4 zeros, next FFF ಅಂತಂದ್ರೆ ಏನು ಎಲ್ಲ 1 1 1 ಇರ್ತದೆ. Next ಅನ್ನು ಎಲ್ಲ 4 zeros, next all ones. So these are changing lines. Next all 3 4 zeros, right? 4 ones. So I will write the address here. 0th address 1 2 3. I am elaborating this. 4 5 6 7 8 9 10 and 11. Right? What is happening here? They are the changing lines here. You see the last nibble. Last nibble I will write. Last nibbles 0 means all 0 0 0. 3 is how much? 3 is how much? Huh?
0 0 1 1 1.
0 0 1 1. Now tell me the memory address. ಇಲ್ಲಿ ಎಲ್ಲಿ ಬಂತು 11 ಆಯ್ತು. So this is address 12, this is 13, this is 14, then this is 15. Yes or no? This is
Yes,
15.
ma'am.
So you observe along with 0 to 11, even 12 and 13 are also what? 12 and 13 are also what is happening? They are changing here, 0 to 1. Whereas 14 and 15 are remaining constant. Yes or no?
Yes, ma'am.
Yes, ma'am.
14 and 15 are becoming as 0, 0 for first 16k. Right? Next 16k, what is the address next 16k? 3FF ಆದ್ಮೇಲೆ ಮತ್ತೆ ಏನಿರ್ತತಿ? ನೆಕ್ಸ್ಟ್ ಏನ್ ಬರ್ತತಿ ಮೆಮರಿ ಲೊಕೇಶನ್? 3FF ಆದ್ಮೇಲೆ ಏನ್
0,
ಬರ್ತತಿ?
0, ma'am.
3FFF ಆದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಮೆಮರಿ ಲೊಕೇಶನ್ ಯಾವುದು? What is the next memory location? ಒಂದ್ ಆಡ್ ಮಾಡಿದ್ರೆ ಆನ್ಸರ್ ಎಷ್ಟು ಬರಬೇಕು? ಹೆಕ್ಸಾಡೆಸಿಮಲ್ 3FFF ಐತೀಗ ಮಾಮೂಲ್ ಕೌಂಟಿಂಗ್. 3FFF ಆದ್ಮೇಲೆ ಏನು?
3000, ma'am.
ಆಕಾಶ್ 3FFF ಇದಕ್ಕೊಂದು ಆಡ್ ಮಾಡಿದ್ರೆ ಏನಾಗ್ತತಿ? 3000 ನ FFFF ಐತಿದೆಲ್ಲ. ನೆಕ್ಸ್ಟ್ ಏನಾಗಬೇಕು? What is after F? What is the next count? Bari one single F tugori. What is the next count?
0, ma'am.
Huh?
10, ma'am.
10. Howda? Next,
Yes, ma'am.
2 FF tugori. After this, what is the next count? 2 FF ಆದ್ಮೇಲೆ what is the next count? ನಾವ್ ಹೆಂಗ್ ಡೆಸಿಮಲ್ ನಾಗ 100 ಬರಿತೀವಲ್ಲ, 9 ಆದ್ಮೇಲೆ 10.
Yes.
ಇಲ್ಲಿ ಏನಾಗ್ತತಿ? F ಆದ್ಮೇಲೆ 10. ಇಲ್ಲಿ FF ಆದ್ಮೇಲೆ ಏನಾಗ್ತತಿ? ಇಲ್ಲಿ
100.
100. ಸೊ ಟ್ರಿಪಲ್ F ಅಂತಂದ್ರೆ ಈಗ ಟ್ರಿಪಲ್ F ಅಂತಂದ್ರೆ
1000.
it is 1000. So already there is 3 is there. So what this will be? After 3FFF, what will be the next memory location? Huh? What is the next memory location?
1000, ma'am.
1000 ಹೆಂಗಮ್ಮ? ಬರೀ 3FF ಇತ್ತಂದ್ರೆ 1000 ಆಗ್ತಿತ್ತು. ಇಲ್ಲಿ ನನ್ನ ಕಡೆ 3FF is there. This value is there. What is the next memory location after this? ಇದಾದ್ಮೇಲೆ
4000.
hexadecimal counting ಏನು? 3FFF ಆದ್ಮೇಲೆ what is the next hexadecimal count?
4000.
Huh?
4000.
Next is 400 is the next memory location. ಅಂತಂದ್ರೆ ನಾನು next 16 kilobyte starting and ending address ಹೇಳ್ರಿ. So next 16 kilobyte in starting and ending address ಏನು? First one 000 to 3FF ಆಯ್ತು. ನೆಕ್ಸ್ಟ್ ಒನ್ ಏನಾಯ್ತು? 4 zeros to
4F, ma'am.
4 zeros to
4F.
4FFFF. ಹೌದಾ ಇಲ್ಲ?
Yes.
So next you observe only this nibble. What is happening? This nibble ಅಂತಂದ್ರೆ ಏನು? 4 ಅಂತಂದ್ರೆ ಏನು? 0100. Next 01 4FF ಅಲ್ಲ. 4FF ಅಲ್ಲ. What is the next one? 4 zeros to next memory location ಏನು? ಇದು 1 ಆಗ್ಬೇಕಿದು. 011 ಅಂದ್ರೆ ಎಷ್ಟು?
7FF, ma'am.
7FF ಬರ್ಬೇಕಿಲ್ಲಿ. ತಿಳಿತಾ? ಇಲ್ಲಿ ಮಟ ಕಾನ್ಸ್ಟೆಂಟ್ ಲೈನ್ ಇರ್ತತಿ. ನೆಕ್ಸ್ಟ್ ಏನಾಯ್ತು? ಇದು ಮೆಮರಿ ಲೊಕೇಶನ್ ಏನಾಯ್ತು? 01 ಆಯ್ತು. ಹೌದಾ ಇಲ್ಲ? ಫಸ್ಟ್ 16 kilobytes ಇಂದ ಅಡ್ರೆಸ್ 4 zeros to 3FFFFF. ಫಸ್ಟ್ 16 kilobytes. ಸೆಕೆಂಡ್ 16 kilobytes ಇಂದು 400 to ಎಷ್ಟಾಯ್ತು? 400 to 7FFF. ನೆಕ್ಸ್ಟ್ 16 kilobytes ಇಂದು ಏನು? 7FFF ಆದ್ಮೇಲೆ ಏನು? 7FF ಆದ್ಮೇಲೆ ಏನು?
8000.
8000, ma'am.
8,000. 800s to.
8,000.
ಸೊ ಅವಾಗ ಏನ್ ಚೇಂಜ್ ಆಯ್ತು ನೋಡ್ರಿ. 8 ಅಂದ ತಕ್ಷಣ ಏನಾಗ್ಬಿಡುತ್ತೆ, ಲಾಸ್ಟ್ ನಿಬ್ಬಲ್ ಅಷ್ಟೇ ಬರೆಯಕತ್ತೀನ ಇದು. 8 ಅಂತಂದ್ರೆ ಏನು, 1000 ಆಯ್ತು. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಏನಾಗ್ಬೇಕು, ಒನ್ ಝೀರೋ ಒನ್ ಒನ್ ಅಂತಂದ್ರೆ ಎಷ್ಟು, ಹೌ ಮಚ್ ಇಟ್ ಈಸ್, 1011 is how much, 8,000 to Vaishnavi. What is the next address? 60k 16k add ಮಾಡ್ರಿ ಅಲ್ಲಿ. ಹಾ
11 ಮ್ಯಾಮ್.
11 ಗೆ ಏನಂತಾರೆ,
11
1011 11 ಅಂತಂದ್ರೆ ಏನು, ಹಾ
11 3F.
ಆಕಾಶ್ 11 ಗೆ ಏನು, 1010 is 10, 1011 ಎಷ್ಟು,
11 ಮ್ಯಾಮ್ BFFF ಬರುತ್ತೆ.
ಹಾ BFFF is the next answer.
Yes ma'am.
So next
B3F.
another 16 kilobytes of the next ಇನ್ನೊಂದು 16 kilobytes ಏನು, another 16 kilobytes BFFF. B ಆದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಕೌಂಟರ್ ಹೈಯರ್ ಆತಂದ್ರೆ ಏನಾಗಬೇಕು,
CFF.
C0002. ಫೈನಲಿ ಏನ್ ವ್ಯಾಲ್ಯೂ, C ಅಂತಂದ್ರೆ ಏನ್ ಬಂತು, 10 ಆಯ್ತಂದ್ರೆ C ಅಂತಂದ್ರೆ ಏನು, 1100. ಹೌದಾ, C all zeros to next memory location ಏನು, ಎಲ್ಲ ಫೈನಲಿ ಲಾಸ್ಟ್ ಒನ್ ಯಾವುದು, 64 kilobytes. Last one is
4F ma'am.
all FFF.
Yes ma'am.
Yes, all FFFs. So that means what, FF. So you observe that from A0 to A13 there are changing lines, whereas A14 and A15 are remaining constant. So for first 16 kilobytes A14 to A15 are 00, second 16 kilobytes A14 to A15 are 01, third 16 kilobytes A14 to A15 are 10, and the fourth block of 16 kilobytes A13 and A14 are 11. Yes or no?
Yes ma'am.
Is it clear to you all of you? Yes. ಇಡೀ ಕ್ಲಾಸು ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಇದನ್ನು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮನೆಗೆ ಮಾಡ್ಕೊಂಡ್ ಬರ್ಬೇಕು, ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ದಟ್ಸ್ ವೈ ವಾಟ್ ಐ ಆಮ್ ಡೂಯಿಂಗ್ ಹಿಯರ್ ಇಸ್, ಸಿ there is no change in address from A0 to A13. Yes, so that's why what is being done, that's why A0 to A13 whatever address is there, the same address is being connected to all the three, A0 to A13. The same address is being connected to all the 4 16 kilobytes of memories, 1, 2, 3 and 4. Whereas check about this A14 to A15 lines are being connected to the mux here. What kind of mux is being used? 2 address, 2 to 4 mux. 2 to 4 mux is being used. So when this address bus is 00, what will happen? 2 to 4, 0, 1, 2 and 3. So 0 is connected to the enable of this memory. So whenever the address bus is 00, this memory is being selected. When which address lines? 14 and 15. So when 14 and 15 are 1, this is connected to the enable of this memory. So second is selected. When it is 2, then this is selected. When it is 3, then the fourth 16-bit memory is selected. So thus what is happening? Thus what we have done, we have configured 4 16k memories to composite it to 64 kilobytes of memories. There is no change in the width. Data is remaining the same. I will clear this. I will use some other pen for data. Look at the data. Data in D0 to D7 is there, same thing. The same data is connected here because separately each chip is being selected. So D out is also connected. What? First time 0 from here D0 to D7, from here also D0 to D7, D0 to D7, D0 to D7. So the same select lines A14 to A15 are also connected. At the output side also the same mux is being used. So whenever 0 is selected, the data from this will be selected. Whenever 1 is selected, data out from this, 2 this fellow, 3 this fellow. Is it clear to you all?
Yes, ma'am.
Very important. You can take the screenshot of this, all of you. Take the screenshot of this. At home you can do it once again. Neatly you can do. All of you have taken the screenshot.
Yes, ma'am.
I am also trying for a snapshot. Let us see how it goes. Yes, done. Is it clear to you all how to make the composite memories? Have you taken the screenshot?
Yes, ma'am.
I will clear all. So the same thing you can see here. So that's why now is it clear to you all why address bits 14 and 15 are decoded? Is it clear to you all? See,
Yes, ma'am.
ವಿಡ್ತ್ ಜಾಸ್ತಿ ಮಾಡ್ಬೇಕಂದ್ರೆ ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ವಿಡ್ತ್ ಜಾಸ್ತಿ ಮಾಡೋದ್ನಾಗ ಲೆಂತ್ ಜಾಸ್ತಿ ಮಾಡ್ಬೇಕಂದ್ರೆ ಕಂಪಲ್ಸರಿ ಈ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಅಡ್ರೆಸ್ ಡಿಕೋಡಿಂಗ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡ್ಲೇಬೇಕು ನೀವು, ರೈಟ್? ಸೊ ದಟ್ಸ್ ವೈ ವಿಡ್ತಿಗೆ ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಗ್ಲಿಲ್ಲ. ವಿಡ್ತಿಗೆ ಏನಾಗ್ಬಿಡ್ತು, ಸೇಮ್ ಅಡ್ರೆಸ್ ಬಸ್ ಹೋಯ್ತು, ಡೇಟಾ ಬಸ್ ಬೇರೆ ಬೇರೆ ಡೇಟಾ ಬಸ್ ಬಂತಷ್ಟೇ. ವಿಡ್ತ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ವೆನ್ ಯು ವಾಂಟ್ ಟು ಇನ್ಕ್ರೀಸ್ ದ ಲೆಂತ್ ಆಫ್ ದ ಮೆಮರಿ, then lot of homework you need to do. So that's why address bits 14 and 15 are decoded to select which of the 4 memory components is enabled to read or write the operations. And the same those bits are used to control the multiplexer to select at the output date also. Same type of multiplexer output side use madivasti from the enabled component during the read operation, right? So that's how you are doing the composite memory. Okay, so we'll stop here. What we'll do? 1 second.